So some clicker issues. Let me see with the team. Nope. The arrows, okay. Let me try the arrows. I think, no, it's gone. Let's go back to, okay. Okay, so to get us started, decision makers need high quality, trusted information on greenhouse gas emissions to take effective actions to reduce those emissions. Now, our session is focusing on methane, and the first question is, why methane? So the two greenhouse gases that contribute the most to climate change are CO2 and methane, with methane being the second most important contributor. Now, methane has a very high global warming potential. Over a 100-year period, methane can trap, 1 ton of methane can trap as much heat as 28 tons of CO2. And if you look at it over a 20-year period, that number, the global warming potential, is much higher. It's over 80. So there's a big need to reduce methane emissions to manage the near-term temperature increases. Now, when it comes to sources of methane, there are different sources, but the big ones are generally oil and gas, agriculture, and waste. And the importance of each sector can vary from region to region and country to country. Now, to effectively reduce methane emissions, policymakers need comprehensive, timely, transparent, and accurate measurements of emissions to take those effective actions. Now, on the topic of measurement of emissions, methane is particularly difficult to measure. There are massive discrepancies in methane emission estimates, and these discrepancies exist at the national level and also at the global level. So here in this figure, you can see estimates of methane emissions in the Saudi oil and gas sector. And you can see estimates by the IEA. You can see estimates by EDGAR, which is the European Commission's emissions database. And you can see the official estimate that was submitted by the Saudi government to the UNFCCC in the 4th national communication. So here you can see that we're looking at a difference, an 8-fold difference in methane emissions for the Saudi oil and gas sector. And this isn't unique to Saudi Arabia. This discrepancy exists in most countries and at a global level. So there you can see a comparison of global oil and gas methane emissions. This is from the IEA's latest report, the Global Methane Tracker, that was published in early 2024. And you can see the IEA estimate of global methane emissions. You can see the sum of all of the estimates that the governments made in their submission to the UNFCCC, and that's about half of the IEA estimate. So the IEA is about 80 million tons. All the UNFCCC submissions together are 40 million tons. And if you look at what oil and gas companies are reporting, and these are oil and gas companies that are part of the Oil and Gas Methane Partnership, scaling that up to include all of the remaining companies, you get an estimate of about 5 million tons. So 1/16 of the UNFCCC estimate. And if you look at the gap between the OGMP estimate and the IEA estimate, that's a 32-fold difference. So we're looking at these massive divergences and discrepancies in methane emission estimates. Now, I want to talk a little bit about the methods for measuring methane. Now, most of those estimates that you saw were generated using the activity-based method. So this is what governments are required to use when they submit national inventories to the UNFCCC. And this works like this. You have your activity data, and this could be gasoline consumption in a country, it could be oil and gas production, and you multiply that by an emission factor to get the emissions in a certain sector. And most of those estimates were generated using the activity-based method, which is probably the most widely used. Now, there are other methods to measure emissions. There's the use of ground-based sensors, and there are the top-down methods, whether through the use of satellites, aircrafts, or drones as well. Now, even when it comes to satellites, there's not a single satellite that provides measurements of methane emissions. there's a wide range of satellites, and there are more and more satellites being launched as we speak. Now here you can see an example of these satellites. Some of them have high resolutions, and they can detect methane for specific facilities in specific locations. Other satellites can cover a wider area. So these are the area flux mappers. And one of them is the Tropomi instrument aboard the Sentinel 5P satellite. And this is the one that we use to measure methane emissions for the Arabian Gulf countries. Now we partnered with Kayrros, and I'm delighted to have Antoine joining me today on the panel. And we used Tropomi to measure annual methane emissions in these 5 Arabian countries. And I want to focus on annual. This is not a single day super emitting event. We looked at a series of images throughout the year to get an annual estimate for these countries. Now we focused on 2 sectors, the oil and gas sector and the urban area sector, where the urban area sector is mostly capturing or reflecting methane emissions from waste. Now there are different methods that can be used to infer the volume or the quantity of methane emissions from the satellite measurements, because those measurements are generally in concentrations, methane concentrations. There's the wind-rotated method, and there's the basin inversion method. Now we use and combine these different methods to obtain our annual estimates for the 5 countries, depending on each country's geographic characteristics. Now here on the right-hand side, you can see an example of the wind-rotated method, and you can look at how we obtain the images and filter them, how we adjust for wind rotation, hence the wind-rotated name, how we aggregate the images, and then quantify the methane plume. Now there are some locations or assets where methane measurement using satellite can be challenging. So for those assets, we extrapolated their emissions, their methane emissions, based on the assets that we had satellite measurements on. So there were extrapolations used to ensure we had comprehensive coverage and that our estimates could be compared to the other external estimates that exist out there. Now here you can see some of the results for Saudi Arabia, the oil and gas sector, and UAE's oil and gas sector. And obviously you can see the massive divergences in methane emission estimates from different sources. So you're seeing EDGAR and the IEA that I spoke about before, but other sources as well, such as Climate Trace and some academic publications in the literature as well. Now, you can also see our satellite estimates in the gray columns. And we've presented them with the uncertainty bars to show that there still is uncertainty in these measurements. Now, the first thing that you can see is that with our satellite measurements, the estimates by the IEA and EDGAR are generally far above the upper bound of our satellite measurements. And you can see that both for Saudi Arabia and the UAE. Now, in the case of the UNFCCC submissions in Saudi Arabia, one of the submissions was within the lower bound of our uncertainty range, while the other was lower. And in the case of the UAE, both submissions were below the lower bound of our uncertainty range. Now here you can see the results for Oman's oil and gas sector and Kuwait's oil and gas sector as well. Now for Oman, we found that the estimates were generally more consistent than the other countries, with one estimate from the academic literature being significantly above the others. I should also mention the parentheses, the numbers in parentheses are the years, because there are different reporting years from these sources, so we've shown those different reporting years here. Now, when it comes to Oman, many of the estimates are actually within our satellite estimates uncertainty range, including the official estimates submitted to the UNFCCC from the focal point of the Omani government. Now, in the case of Kuwait, it's a similar story to the other countries where the estimate by the IAA was far above the upper bound of our satellite estimate, but the UNFCCC submission was below the lower bound of our satellite estimate. So again, this helps kind of answer some of those questions about those divergences and which of these estimates might be more accurate, and also highlighting how these divergences really exist, not for countries all around the world. Now, this is a comparison using our satellite measurements of methane emissions for the oil and gas sector. And obviously, when you look at the 5 countries here, Saudi Arabia, Kuwait, Iraq, UAE, and Oman, we're looking at different levels of oil and gas production. So we're comparing these countries using methane intensity. So this is kilograms of methane per barrel of oil equivalent produced, so controlling for the production. And the key message that emerges from this particular figure is that Saudi Arabia and the UAE are the top performers in the region. So those two countries have significantly lower methane intensities for their oil and gas sectors compared to their other Arabian Gulf countries. Now, we also did a broader methane intensity comparison. So first we did it using methane data from the IEA. And you can see the value or the intensity value using the IEA data. You can also see the rankings using the IEA data. So although we showed with satellites that the IEA data is significantly above the upper bounds for many of these countries, even using that IEA data, these countries were generally top performers around the world when it comes to the methane intensity of their sector's oil and gas production. And when we used our satellite estimates instead, all of these countries saw improvements in their methane intensity, with Saudi Arabia becoming the second ranked and the UAE being the third ranked among selected oil and gas producers that produce at least 1 million barrels of oil equivalent per day. And for those that are curious who's number one, it's Norway. So maybe not a surprise for many of us. So to summarize, countries can benefit from incorporating satellite measurements into their greenhouse gas inventories. I've talked about the massive discrepancies. I've showed them at the national and at the global level. And satellite technology really is becoming a more effective tool for timely and transparent measurements of methane emissions. Now, there are different methods. I mentioned the activity-based method, satellites, and there are other methods out there. And they each have their strengths and weaknesses. So there is a lot of value from combining methods to really provide policymakers with the most comprehensive, timely, accurate, and transparent measurements of emissions and help them implement effective actions to meet national and global climate goals. Thank you.
Thank you. Thank you, Anwar, for this insightful presentation, and thank you, everyone, for your attention. To start, please allow me to introduce our panelists today. We have Anwar Qasim from KAPSARC. He's a Principal Fellow in the Climate and Sustainability Program. We're also joined today by Jonathan Banks, the Global Director of Methane Pollution Prevention at the Clean Air Task Force, and also by Antoine Haaf, the co-founder and chief analyst at Kayrros. To start off, Jonathan, if you could start with some opening remarks.
Sorry, didn't realize I was going first, but it helps to have the microphone. First, thanks for the invitation to be here. It's always a little bit amazing to me. I should stop being amazed. It's always a little amazing to me to see how things have changed here at COP over the years on methane. I first started working on methane when the first science on short-lived climate pollutants emerged in 2000. Back then, you couldn't even get anyone to talk to you about methane here at COP. So it is a sea change in what is going on here at COP. It's a sea change in not just the talk, because the talk doesn't mean anything, but it's a sea change in the action that we're seeing on a global basis. The data piece is probably one of the more astounding things. The work that's gone on to increase our understanding of emissions. We've long known that there's huge issues with the data in emissions coming from the oil and gas sector. As the understanding of emissions has increased, we have learned that almost always, not always, but almost always, there are more emissions than we thought there were. Reported emissions are almost always underestimated. And when you look at the United States, where there's probably been more studies done than any other place in the world, the scientific evidence shows that we're underestimating emissions by about 60% in our reported emissions. There are still discrepancies, though, in all of the data. And I think the important thing about data is we constantly want it to improve. It will never be perfect, and so we have to act now. And I think that that's the key piece is as we improve our understanding of this, we accept the imperfections of the data and we take action on the things that we can do. And there are tons of things within the oil and gas sector that we can do to take action right now that you don't need to have measurements for. You don't need to know the perfect data to institute an LDAR program. You don't need to have the perfect data to stop flaring, to stop venting. You don't need perfect data for any of these things to take place. As we do these things, we will learn more about emission sources, and the data will constantly be improving. If you had told me just a few years ago that a couple of NGOs would launch satellites, I would have told you you were crazy. But today, we have Environmental Defense Fund launched a satellite. Another organization, Carbon Mapper, has launched a satellite, and just today, their satellites released their first pool of data with hundreds and hundreds of images of plumes from around the world coming out. I would encourage all of you to go see it. It's fascinating to look at. I am not a satellite person, though. I can look at pretty images of satellite emissions and get really excited about them, but I'm not a satellite person. At the end of the day, I'm an end user. My job is to affect change around the world by working with governments to institute the kind of policies that make those images go away. And so I constantly look at the issue of satellites as how can I use this to affect that change that's necessary to actually see the emission reductions. And it's really exciting to see this whole new dawn of data coming forward. But I think we have to really think about how do we move from this data-rich environment. We've come out of the desert where there was no data to this data-rich environment. How do we move from the data-rich environment to an environment rich in action? And I think that's the really key piece that we have to address. And I'll stop there because I know we're going to get into a bunch of things when we get into the Q&A. So
Thank you, Jonathan. Antoine, as the satellite person in this panel, what are your opening remarks?
First of all, thank you very much for the invitation and the opportunity to speak here today. Second, I would like to say it's been a great pleasure and really inspiring to work with KAPSARC on this study. KAPSARC we've been working together for now, I think, 3 years. KAPSARC has been one of the first major institutions around the world to adopt and to appreciate the potential of satellite monitoring and to put it to use. So I think that's been extremely constructive and very, very fruitful, and we're really thrilled about this. The results, of course, for Saudi Arabia have been very good because we see that it's the best in class or second best in class in a very large class in terms of the performance and the methane intensity. And the UAE has been doing very well. So that's great validation, that's wonderful. What I would say is that for the countries that do not perform as well, there's no reason to be upset about that. It's very important to get the numbers right. And it's better to get the baseline right, and if the baseline is high, it's better to have that baseline correct so that we can identify the opportunities for abatement and that we can measure the trajectory correctly. What counts is not just what emissions are today, that's very important, but what counts also is how we can abate methane, how we can reduce the footprint and do it fast and do it at scale in a very short period of time because time is lacking, time is running out. And if we underestimate emissions where emissions are high, we undermine the potential to reduce those emissions. So it's extremely important to get the numbers right, to get the baseline as it is, and it's going to be much easier for the high emitters to reduce their emissions and to show good performance in the future if they own up to the high level of emissions today. The other thing I would like to say is, well, satellites have been a game changer. And it's not been just the instruments themselves, the hardware. It's been also the processing capacity, the software, the algorithms, the artificial intelligence that's been used to process the imagery at scale, to extract maximum information from the images, and to do it at record speed, to do it as it happens in near real time. There's three main ways in which satellite monitoring can be used today for detections of methane. And I would just want to mention them briefly. One is country-level inventories. This is what the study was about. And that's very useful to identify the inventories, the baseline, to set countries on the right trajectory, to report to the UN FCCC. Another way is to detect super emitters. If we had chosen that approach with Saudi Arabia, it would have been not very interesting because there's not that many of them. But around the world, there are many super emitters. There's thousands of them per year, and even more depending on where you draw the line, how you define a super emitter. Why is it important to measure super emitters? They're not the whole picture. They're maybe they're the very large emissions, very, very concentrated, intermittent, not lasting very long, but releases of methane that in a few hours can release the equivalent of the total carbon emissions of tens of thousands of cars over an entire year. So they're very, very important. There's an argument out there that there's a tendency to overestimate the importance of super emitter, and we have to get the full picture, they're only the tip of the iceberg. I don't fully agree with that argument. I think we have to obsess about super emitters because they are the low-hanging fruits. They are easy to see, they are easy to fix, easy to address. When you address them, you have a high impact because they're very concentrated, and they're morally indefensible. They cannot be justified. They're really due to bad operating practices or defective equipment that needs to be replaced. They should not be tolerated. And I think the policy should target super emitters even more strongly than it does today. And the third way in which satellite monitoring can be used is by monitoring supply chains. And that's an approach which is coming very much at the forefront in the context of new regulations in the EU in particular, which require the reporting of emissions not just in the EU, but also of imported emissions associated with imported oil and gas. And so for trading purposes, in the next few years, we're going to see the likelihood of tariffs imposed on imports that come with a high methane footprint. So monitoring the supply chain, benchmarking the performance of different producers, different suppliers is going to be increasingly important. And that's something that we work very hard on at Kayrros. And just the day before yesterday, we unveiled a partnership with Engie, a big utility and natural gas and electricity supplier in France, to do just that, to assess, to benchmark their supplies and to monitor the footprint of everything they bring, that they import and that they trade internationally. So that's going to be very important looking forward. And the last point I would like to make is that satellites have their limitations. There's always, they have their limitations because there are some areas where they perform less well than others. They're still not as effective offshore as they are onshore, although that hurdle is going to be overcome very soon, is beginning to be overcome. But they also have, there's always a give and take with satellites. No matter how good they are, there's always a give and take between the spatial resolution, the temporal resolution, the revisit time, how frequent they are, the coverage, geographic coverage, and the spectral resolution, the sensitivity. And typically, it's possible to optimize for two of these variables, but at the expense of the third. So you can be very precise, have good granularity, have a very high sensitivity and high spatial resolution, but that's going to be at the expense of your coverage and your frequency. Or you can have very high frequency, but less granularity. That being said, what we do at Kayrros is that we fuse data from multiple satellites, and through this approach of data fusion, of combining different assets, different measurements, we can create a synthetic satellite monitoring system that combines the best of all these approaches. So we can combine the very high resolution and global coverage of instruments like Sentinel-5P and the very fine 3.5 meter spatial resolution of something like Maxar Worldview. And that's something that's very, very powerful, and which is going to be even more powerful in the next few months and years as more satellites come online, like Methane Sat, which was launched in March, or Carbon Mapper, Tanager 1, which was launched in August. These satellites have improved capabilities. They still have their give and take, but by combining these satellites with other inputs, we're going to have incredibly powerful monitoring systems.
Anwar, in your presentation, you mentioned how difficult it can be to measure methane emissions. So what exactly are the advantages of using satellite technologies over other methods, and what are some of the trade-offs?
Great question. So one of the big advantages of satellites is transparency. And that's been a big theme for methane emissions this year, transparency. So the move towards more transparency when it comes to the measurements of emissions. Timeliness is another big advantage, because with satellites, you can have a measurement of methane emissions from just an image that was taken a few days ago, taking into account the time that you need to process that image. So timeliness is a big, big advantage. And I think when it comes to accuracy, satellites can deliver a lot on accuracy, especially if methane emissions are measured using activity data and a default or an average emission factor that's not being measured. I think that can be very inaccurate. Now, obviously, a weakness is comprehensiveness. So as Antoine mentioned, we were unable to obtain satellite measurements from offshore oil and gas fields. So you had to extrapolate their emissions based on the satellite measurements for the onshore fields and comparing the intensities. So there are areas where satellite measurement is difficult. So it cannot give you comprehensive coverage. Now, on the other hand, for example, with the activity-based method, you do have that comprehensive coverage. So you can cover with the right activity data all sectors and subsectors of the economy. But that, for example, tends to come at the cost of timeliness. Now, if you look at most national greenhouse gas inventories that countries submit, there's typically a 3, 4, 5, 6 year lag. So there's a big lag because it takes a lot of time to collect that data and to build a comprehensive national greenhouse gas inventory. So different strengths, different weaknesses to these methods. And I think there's a big value from combining them and going for a hybrid approach. So you can really benefit from the strengths of each method.
Jonathan, let me ask you, having this data available, how can policymakers really utilize this level of granularity and use it to achieve their sustainability targets?
It depends a lot on the country. I think one of the issues that we have is the capacity to receive and utilize information at a country level depends a lot on each country. We were talking before, but since not everyone was listening, I'll tell the same story. In certain countries, Argentina is a really good example of this. Within the Ministry of Energy, the department that deals with oil and gas deals with all aspects of oil and gas. From gas stations to offshore drilling, health, safety, environment, everything. They do it all. There's about 8 or 9 people in that department. When they're doing an offshore lease sale, that's all they do. All 9 people are working on the offshore lease. If during that time they receive a message from Mars, the Methane Alert and Response System, that, you've got an emission event happening at a YPF facility in the Vaca Muerta. Those 9 people are really, really busy at that time. It's difficult to say, okay, how do we get this data out to YPF? How do we follow up with it? How do we actually make sure this emission event disappears? So I think we have a real human capacity issue. It's not that they can't comprehend it. They have all of that capacity. But you have a real human capacity issue to take action that we're going to have to develop systems to overcome. And it doesn't mean, we have to create large bureaucracies in every single government around the world to deal with these emission events. But we are going to have to come up with solutions that can build the kind of capacity through trainings of how to understand this data, how to take action on this data. Most of you are probably too young to understand what a phone tree is. Does anybody know? You know what a phone tree is. Phone tree used to be like when we didn't have text messages and all that stuff. It's like you could call one person and that person then would call one person, that person. So it would create this like tree to like make sure that the alerts got out to where but you kind of need, within governments, you need designated phone trees for alerts so that within the government, when there's an event, someone who's the designated contact point has a way to reach the person within YPF in that field. That these pathways are not designated. And so there is a gap here in how this data is processed and used. That's just on like super emitter events like Antoine was talking about. That's one issue. How you utilize the satellite data to inform overarching policy within a government is another thing. The government of any country is not going to take data from IMEO or EDF or Carbon Mapper and just take that and bless it and say this is our inventory. You have to figure out how to integrate that into the inventory, and we have some issues in that there are some hindrances in like UNFCCC reporting that can be navigated, but it sure makes it difficult to be able to integrate it fully into reporting. So there's a lot of barriers in the system that we're going to have to find ways to overcome, but they're all totally surmountable. It just requires us to better understand where these barriers exist and then to come together to really collectively overcome them. But we're in the early stages really of exactly how it's going to inform policy. I think the one that needs to be figured out and should be figured out, as Antoine was pointing out, the fastest is this super emitter phone tree. We basically need to create a system that allows each country, whether it's Kayrros or IMEO and Mars or Carbon Mapper or EDF, it allows for that data to flow to the action-oriented people in the field that can actually reduce the emissions. So I think that's the piece we have to tackle the most quickly. And then the other aspect of like figuring out how we incorporate it into inventories and then how that informs policy, that one we can work on in a different pathway.
If I can add to that, so we actually looked at the IPCC guidelines. So when countries report their emissions to the UNFCCC, they're following IPCC guidelines, and there's different iterations. So there's the 1996 guidelines, 2006, the 2013 refinement, and the 2019 refinement. And right now, with the BTRs that countries are submitting right now, they're using the 2006 IPCC guidelines. And we looked for the mention of satellite technology in those guidelines. And in general, it's mentioned very much as an experimental technology. So early stages, experimental technology, and so on. And that's not surprising because if you go back to 2006, if you go back to 2013, even to 2019, there weren't really that many satellites out there. I think in 2019, you had Tropomi was launched, I think in early 2019. And there's been this explosion in the number of satellites that were launched and that are being launched this year and next year as well. So yeah, I mean, there's a potential to update those guidelines, encourage more active use of satellite technology, but these processes, updating the IPCC guidelines and then through the UNFCCC, getting countries to adopt newer versions of those guidelines is quite time-consuming.
Antoine, going back to the issue of data and the quality of data, we talked a bit about the limitation of satellite data. How can we combat these limitations? How can we improve the performance of satellites? And how can we prove the accuracy of the data that we're receiving?
So the performance is pretty good, actually, I think.
Okay.
It's improving because there's more and more images. So the more images we have, the more visibility we have. The new sensors have improved capabilities, so there's more sensitivity, they're better designed. The more we learn and the more we learn. So it's a learning curve, but it's very high performance, and we already know more than enough to take action. We're going to know even more. How do we prove the accuracy? That's a good question, because oftentimes satellites measure things that cannot be measured otherwise. local sensors, there's not that many of them by definition. They're on the ground. They often sometimes can detect emissions. Sometimes they can't see the emissions. They almost never can measure the emissions. You really need to have a view from space to measure the emissions. Even aerial surveys or drones can detect emissions, usually not very well measure the emissions. There's limitations in measurement. Satellites typically are the best in measurement. They're the best in detections, and they're very good at detecting supermeters that are very distributed geographically. I mean, there are some facilities that are chronic emitters, but supermeters are very brief, very intermittent. By definition, they are missed by aerial surveys or drone surveys that can only happen once a quarter, once a year. That are very expensive. So there are things that we see with satellites that we cannot measure otherwise. So how do you prove the accuracy of these measurements? One approach that's been adopted has been to organize controlled releases of methane and to task satellite teams to detect those releases with satellites and to measure them. And there's been two major rounds of experiments that have been done by Stanford University, which have been now published in peer-reviewed top-quality scientific journals, including Science. And those studies brought together a number of participants who participated in them, and they've really validated the accuracy, the high performance of satellite monitoring. And we performed particularly well. Our company performed, had the most detections, and the measurement, everything was really great. But none of the participants came up with a false positive, which is a big concern. The big fear is to have a false positive, a false alarm, and then to allow emitters to say, no, this is not reliable because you have false positives. We never had any false positive, never happened. Yeah, so that's been the approach. There's more of those controlled releases that are being planned in increasingly difficult, challenging conditions to continue to test the capacity and to push the limits of satellite monitoring.
I see. Anwar, if we can focus a bit more on sectoral specification. We talked a lot about the oil and gas sector. Does this technology lend itself to be used in other sectors, in other emitting sectors?
Thank you for that question. It's working, yes. So I only presented the results for the oil and gas sector, but we did measure it for urban areas and specifically waste sectors there. So this is a good chance to mention the paper has just been published. So if you log on to the KAPSARC website, you can see the paper there. We've got the measurements for the other sectors. So you can see the measurements for waste. And I think it's quite interesting because, and I haven't shown this in the slides, but basically if you look at the IAA data, they're saying 90%, and I'll focus on Saudi Arabia only because I have the numbers off the top of my head. 90% of all methane emissions are coming from the oil and gas sector, and very little from waste. And then in the UNFCCC submission, they're saying 2/3 of emissions are coming from waste and only 1/3 from oil and gas. So not only are you having these discrepancies by sector, but when you look at the sectoral breakdown, they're completely different messages for policymakers. And when we looked at it by satellite, we actually found that waste was the bigger emitter in terms of methane emissions in Saudi Arabia, with oil and gas being a third, maybe even a little bit less than 1/3. So it was more consistent with the UNFCCC submission. So we do have estimates for the waste sector, and if anyone's interested, I do recommend checking them out on the paper. Maybe I'll touch on the superemitters. So Antoine mentioned that Saudi Arabia is doing very well in terms of superemitters. Yes, and that's true. But if there have been a few events that we've seen, and they've mostly been from the waste sector. So there is more potential. So once you have data like this, you can tell a policymaker that there is more potential and there's more of a need to reduce emissions from the waste sector, not the oil and gas sector.
Great, thank you. With that in mind, Jonathan, let me ask you, do you see any linkages between better measurement technologies and better methane reduction policies? And what are some of the barriers between detection and action on the ground?
Let me just first say, we don't actually have that choice. We don't have the choice of picking a sector to reduce emissions. We have to reduce emissions in the oil and gas sector, the coal sector, the waste sector, and the ag sector. When you look at what we can do quickly, it's oil and gas. That's what you can do quickly. Doesn't mean it's easy, but that is the one thing we can do quickly. Waste sector, is absolutely critical, but when we work on reducing emissions in the waste sector, we are talking about changing how we handle waste in general. And the solution in the waste sector is not bolting on a technology. It's not putting a pipe on something. It is about a holistic approach to waste where methane is a co-benefit. In around the world, we don't have the kind of waste systems that are designed to get us to the point where we're not seeing methane emissions. We have to have a holistic approach that addresses waste. That's going to take a lot more time than replacing our pneumatic devices with zero bleed pneumatics, or putting VRUs on tanks, or capturing flare gas and putting it to a beneficial use rather than flaring it. We have to address oil and gas in every place and get every drop of methane that we can out of the oil and gas system. At the same time, we build towards our efforts on waste and ag and coal. So I don't think we have that choice. It has to be all of the above, because the reason that everyone is so focused on methane is because it is literally the only thing that is going to bend the curve on climate change in our lifetimes. We have no other tool that will do this. And if we take something off the table, we are setting ourselves into a much bigger hole than we already are in, and we're in a pretty darn big hole as it is. And at this point, I've completely forgot your question. Sorry, apologies, big time.
I'll repeat it. So my question was, where do you see the barriers between detection and policies?
Yeah, I think the barriers. I think one of the barriers that I mentioned earlier was the capacity side of thing earlier. That there's a lack of capacity in governments to be able to receive and process and act on data. I think also we're still in a stage of satellites where there's a lot at the government level. There's a lot of misconception of what satellites can do and what they can't do. I remember a few years ago, we've been working in Colombia since like 2018. A few years ago, the Colombian government had the thought that, okay, we're going to use satellites as our leak detection and repair program. And we counseled them, it might not be the best idea to use for a leak detection and repair program, but they were really keen on it, and it was a fantastic learning experience. They pulled all the satellite data they could for Colombia, and there was this teeny little strip of Colombia you could see, because Colombia is a really lousy place for satellite data, with the mountains, the cloud cover, the forest cover. It's a really lousy place for satellite data. So there is a misconception often of what you can and can't use satellites for. That we're still in this early stage of understanding. I think that's rapidly changing, though. But I think also what we were talking about earlier. It's like governments inform policy to varying degrees by their commitments to the Paris Agreement, their NDCs. The idea is that it's Paris to NDC to policy in country, and there is a gap here in this space of how we start to incorporate all of the satellite data into that mix so that it can be utilized to inform policies. So it's an interesting time. It is rapidly evolving, though. Thank you for repeating the question.
Absolutely. So as we're coming up on time, let me ask one final question to all the panelists here. As we reflect on the progress that's been made on combating methane emissions, and as we are getting ready to see some updated NDCs in next year, what do you expect to see in those NDCs when it comes to methane? Or rather, what are you hoping to see? Antoine, let's start with you.
Well, obviously, I'm hoping to see very aggressive methane abatement targets. If you go back to the Paris Agreement 2015, there was no methane goal at all. Not that we didn't understand the risk of rising methane concentrations, but we didn't know where they came from. We could not measure them. could not track them, could not attribute them. Now we can. So now we have the opportunity to tackle these huge climate risks, 50% of global warming in the next 20 years on current trends. And as Jonathan said, this is our opportunity to bend the climate curve and create the space we need to address longer-term solutions to remove carbon emissions. So really hope that we're going to have very aggressive carbon abatement targets. They're achievable. We can, only by tackling the super emitters, we can remove 2 gigatons of emissions of CO2 equivalent from the atmosphere. So this is high impact. But I think it's going to be driven by NDCs, but driven also by other factors, including the financial sector. Not everything is going to come from government policy. And we're now seeing the financial sector, asset managers, banks, taking a very strong leadership position on methane, addressing, building methane targets into their SDG and net zero plans. And the financial sector is much more ready, I think, to confront methane than the companies responsible for the emissions themselves. From the oil and gas sector, we still see a lot of denial. A lot of companies now have methane targets, have methane reporting, but we find that the methane reporting typically is a tiny fraction of what we can really see the companies emit. So there's a lot of still pushback, denial from industry that needs to be overcome. And I think the financial sector is going to be a driving force in moving things forward and getting us to achieve real results in the next few years, as we must.
Thank you. Jonathan, your perspective on this?
Well, I'm not going to repeat everything that Antoine said because I agree with everything he said. So it's just a ditto to that. To add on to that, I think specifically in the NDC space, we want, there's varying degrees of benefit in the NDCs. At the very least, every country needs to address all greenhouse gases in their NDCs. When the next round comes in, we need to see every country addressing every greenhouse gas. We still have a couple out there that most countries at least have some coverage of all greenhouse gases, but we still have a couple out there that don't address methane in their NDC. We need to see that go away. That's the first baby step that we need. Ideally, we'd really like to see targets specific to methane in NDCs. Me personally, I'd really like to see sectoral targets for methane in NDCs, but I know that's very both sectoral targets as well as just an individual target for methane depends largely on how a country's NDC is regulated within the country. I mean, every country, unfortunately, there's no real governance of how an NDC is supposed to put together, so everyone puts it together in a slightly different way. These NDCs have been embedded into regulatory actions, and so every country approaches it different, and some actually don't have the ability to take sectoral targets because of how they structured their NDC. But ideally, we'd like to just see more and more focus on these, so that there is that that point of attention to driving action specifically on methane. But at the end of the day, an NDC is only worth as the paper it's on, unless we actually have policies in the country that are implemented, enforced, and get the emission reductions we need.
Okay. And what are your perspective?
So going last is always hardest. My panelists have raised a lot of the good points. But I'll reiterate, I think we'd like to see in NDCs economy-wide targets, so going back to the comment about all sectors being covered and all the key greenhouse gases being covered. So not all countries are covering them. Some countries will only mention CO2. We'd like to see CO2, methane, nitrous oxide, and other greenhouse gases as well. Now, maybe if I take a step back, I think of sort of the cycle of the Paris Agreement. So you have your NDC submissions and the targets over there. And then you also have your BTRs, where you're now measuring progress, tracking progress, and how well our country is doing and so on. So I'll say better NDCs, better measurement, and I think countries will need some capacity building now with the BTRs, and we're seeing that being discussed here at COP this year, the need for capacity building with the more difficult requirements with the BTRs, but more ambitious NDCs, better measurement, and I think that'll really help us achieve the goals of the Paris Agreement.
Well, with that, we are well over the time we're allotted, so I'd like to thank our panelists and thank you everyone for your attention. Thank you.